Okay, I've got two equations here. These are linear equations. There are no squares or square roots or anything. And I want to find the values of x and y that make both of these true. Okay, so I want to find there should be exactly one x and exactly one y that makes both of these equations true. Now there are two ways we can see this. The first way is geometric. We graph these two equations and see where the lines cross. Okay. Now it's possible that the lines wouldn't cross because if they have the same slope, they could be parallel and never meet. Okay. Or it's possible that they'd be the same line. They'd have the same slope and they would meet, so that you have infinitely many points that satisfy the equation. That won't be the case here because the slopes are completely different. If I solve this for y, I'll find that the slope is -2/5. If I solve this, I find that the slope is +2/3. So these lines aren't exactly at a right angle, but they're at a pretty big angle. They're going to cross. Okay. So we want to find x and y values that work in both equations. We plug it in here, we get 9. If we plug the x and y in here, we get 9. If we plug the x and y in here, we get 3. That's easy to find an x and a y that work here. If x is 2 and y is 1, 2 times 2 is 4, 5 times 1 is 5, they add up to 9, right? But it doesn't work down here. If x is 2, that gives us 8, right? And then -6, well, that would give us 2, not 3. Okay, so actually, x equals 2 and y equals 1 works here. It almost works here. Not quite. Okay, we want to find the real values of x and y to do that. First thing I can do in a situation we graph both equations. Okay. Easiest way to graph these equations right now the equation I gave you is to find the x-intercept and the y-intercept of each one. So work it out. Find the x-intercept and the y-intercept of this equation. Now, we've found intercepts of rational equations and all kinds of complicated things. This is pretty simple. You just have to know what does it take to find an x-intercept, what does it take to find a y-intercept. And if you don't know that, I'm going to let you kind of ponder it for a couple of minutes before I enlighten you, and then hopefully you'll always remember it because you always have to know, okay? Okay, some people are okay here and some people are less okay. How do you find the x-intercept? The x-intercept occurs when y equals 0. Because the x-intercept is on the x-axis and y equals 0 on the x-axis, right? So hint. So you really have to know what the x-intercept and y-intercept mean. That one intercept occurs when the other variable is 0. Okay, I'm going to go ahead and do this first one. Okay, The x-intercept is what? X-intercept happens if y equals 0. If y is 0, you plug in 0 for y, and you solve the resulting equation for x. And I'm not going to go through the details of solving that equation, but if you can't solve that equation, you really need to get somebody to work you through it, okay? And then if x equals 0, well, you plug in 0 for x, you get 2 times 0 plus 5y equals 9, which gives you 5y equals 9. You divide both sides by 5, you get y equals 9/5. Okay? Now, since we're going to want to plot the corresponding points, we'll change these to mixed numbers so we know where to look, okay, on the axis. So y-intercept, or the x-intercept is at 4.5. The y-intercept is a little less than 2. I can plot those on the graph, but I want to kind of anticipate that, okay, so I think all my intercepts are less than 2, except this one, which is like 4. So I'm going to put 4 out here so that 2 will go here, 1 will go here, 3 will go here. So if y is 0, x is 4.5. Let's put that point 0, 4.5. Here. And then let's put the point, and it's not 0, 4.5, it's 4.5, 0. X is 4.5 when y is 0. So there we have it. Okay, and here we have then 0, 1, and 4/5. I'll go ahead and put 4 all the way up here so that 2 will be here and 1 will be here, 3 will be here, more or less equal scales. My y value will be 1 4/5. So we have the point x equals 0, y equals 1 4/5, which is about here. So these are 2 points on the graph of this function. Function is a straight line, or the equation. The equation gives you a straight line because just the first power of x, first power of y. You could solve it, you could put it in y equals mx plus b form. It's got to be a straight line. So there's my line, and I'll just label that y equals, sorry, 2x plus 5y equals 9. There's my line. Every point on this line satisfies this equation. Now we want to do the same thing for the other equation. Okay, for x minus 6y equals 3. I'm not going to do the algebra, but you would write out the algebra. Well, I'm write it out. Okay. So if y equals 0, we get x equals -1/2. So the x-intercept is -1/2, 0, which will be about here. This is 1. The -1 is going to be about here. That's about -1/2. Okay. If x equals 0, we get 4 times 0. You know, that point's wrong and what I wrote is wrong. Clearly, solution to that equation is x equals 3/4. The x-intercept is then (3/4) 0, which is like here. And the y-intercept occurs when x equals 0. And you get the y-intercept at 0, -1/2. Well, this is -1. -1/2 is about here. And now I can draw a straight line through these points. And that's the picture I get. Now, what are the coordinates of that point? Okay, so the situation then is this line represents all the points that satisfy this equation. And this line represents all the points that satisfy this equation. The points that satisfy both equations would be any points where the two lines meet. Well, that's only one point. At this point, the x and y for this point satisfy both equations because this point lies on both graphs. Now let's make an accurate, honest estimate here. It's not going to be all that accurate. Okay. I can draw a projection line from this point down to the x-axis, and I see that it looks like it's pretty close to 2 from where you're sitting. It looks like it might well be 2. Okay, until I got up close to the graph, it looked to me like 2 was very plausible. Okay, but if I draw it honestly and carefully, I see it looks like about 1.9. Okay, looks like the x coordinate here is 1.9. And the y coordinate, I've got to go straight across here. Looks to me like it's about 2.1. Okay. My projection lines indicate the common point 1.9, 2.1. Okay, so what's the process I've used here? Well, it's to graph these two straight lines. Okay, well, we graphed straight lines in chapter 2 a long time ago, right? So this is kind of a review. And the easiest way to get these lines is probably to find the intercepts. You can also solve for y and get the slope in the intercept, the y-intercept, and use that. And you might need to review chapter 2, which is something that would be good to do anyhow, because you're probably going to see chapter 2 stuff from the exam. Okay. Yeah, we've got a question. Hang on. Okay, well, we had a question, and one observant student asked, isn't that 1.1? Okay, well, obviously, that's wrong because it's not what I said. I didn't say 2.1, I said 1.1. And everybody else, except the person asked the question, verifies that. So, okay, well, yeah, okay, I made a mistake. You've never seen that before. So get over your shock. And thank you for the correction. Okay, 2.1 wasn't going to work very well. Okay, I had 1, 2, or 2, 1 in my head. And of course, my head wasn't working right. Okay, now we understand the process, I hope. Okay, we graph the two straight lines using the techniques of chapter 2. The technique I chose here is find the intercepts. That usually works unless the intercepts are too close to the origin, as they kind of were here. Still, now, let's see how close we are. If I plug in x equals 1.9 and y equals 1.1, how close do I get to 9? And then if I plug those numbers in here, how close am I to 3? In other words, how well did my graph approximate the correct solution? Now, in a minute, we'll go on and find the correct solution. Right now, just worry about how well my carefully constructed graph represented these two functions. Okay, so plug in the coordinates 1.9, 1.1 into the first equation and see what you get. Plug into the second equation and see what you get. If you want to use your calculator, do the multiplication, that's perfectly valid. Okay, so people are doing fine here. So we check to see if these coordinates satisfy both equations. Well, they won't satisfy exactly. And you notice that, this thing's going nice and straight, and that has a little hook here, which kind of threw this point up a little too high and this point a little bit to the left. If I'd have drawn a really straight line here, we probably would have gotten something pretty close to 2 and 1, which would have worked a little better. But if we use these numbers here, we get (9.3 = 9). It's not correct, but it's close, meaning we came pretty close to the solution, at least so far. Now, if we come back down here, we get (1 = 3), not all that close. Okay, so my really nice graph just didn't do all that well. Did pretty well for this equation, didn't do as well for this. Okay, so my original estimate that I just noticed that 2, 1 would be a solution here came out closer. 2, 1 gives us exactly 9, and 2, 1 here gives us 2 instead of 3, which is closer than 1. Still, wasn't too bad, but that's the graphical process. That's what's going on with two simultaneous equations. Now, let me emphasize that it's possible that the two equations could have the same slope that go through different points, so they would never meet, okay? It's possible that they could have the same slope and they could meet on every point. And those distinctions are important. But let's move on. I guess I can do this one. But come on, what do I have here? One thing I have is a need for a little more board space, but I can do this. Okay, sorry, I kind of complicated my life with the way I had the boards stacked there. Okay, let's go back to our equation. 2x plus 5y equals 9, and 4x minus 6y equals 3. And let's find out what the real solution is. Okay, so what I'm going to do here is, first of all, I'm going to write a 1 here with a circle around it to indicate that this is equation 1 and this is equation 2. Okay, so I'm going to rewrite my equations. I'm going to rewrite equation 1 and multiplying every term by 2. So I write 2 times equation 1. Okay, means 2 times every term in equation 1. That gives me 4x plus 10y equals 18, because 2 times 2 is 4, 2 times 5 is 10, 2 times 9 is 18. Okay, and then the second equation, we're going to multiply by -1. So multiply every term by -1. -1 times 4x is -4x. -1 times -6y is plus 6y. And -1 times 3 is -3. Now, why did I do that? Well, what do you get if you add this equation to this equation? So I'm going to do equation 1 plus equation 2. Write down this and then add these two. That meaning add the left-hand sides and add the right-hand sides. You can actually just add them term by term. Okay, so what we get is, should be obvious, that 4x and -4x add up to 0. Because any number and its negative add up to 0. So we get 0. And 10y and 6y is 16y. And 18 and -3, it's like you go up 18, then back 3, leaves you at 15. And then you solve this by dividing both sides by 16. I'm not going to write out that step. Y equals 15 over 16. Now 15 over 16 is really close to 1. But it's a little less than 1, right? Now remember what I did on my picture here. This thing kind of hooked up a little bit. If it had stayed straight, I might have possibly got an estimate of a little bit, tiny bit less than 1. But that would be the accurate number. It wasn't off by that much. Okay? If I kept that line straight, I probably would have come out with a better estimate for Y. I might not have gotten 15, 16. It's very unlikely that I'd be able to read the graph carefully enough to get this, but I got something a little bit less than 1. Okay. Now that I know that Y equals 15/16 at this point, it's easy to find X, because I can just plug 15/16 into either equation and I'll get a solution for X. I'll get an equation that I can solve for X. So what I'm going to do is I'm going to go ahead and I'm going to plug Y equals 15/16 into the first equation. And that's going to give me the equation 2x plus 5 times 15/16 equals 9. Now I solve this equation. What did I do to solve this equation? Well, I've got a denominator of 16. I multiply both sides by 16. So I'm going to say, well, okay, do 16 times 2x plus 16 times 5 times 15 over 16. Of course, I put that all over 1. And that equals 16 times 9 Well, then I can rearrange this to 16 over 16. What I end up with is 32x plus 75 equals 144. Which means of course you want to write this out step by step, but I'm shortcutting it a little bit. 32x is 144 minus 75. So 32x equals 69. And x equals 69 over 32. Which is 2 and 5/32, which is about 2.16. Okay. Approximately 2.16. If you plug it into your calculator, that might be correct, two significant figures. It might not be, I did it in my head. Okay. And 15/16 is 0.9375, I think. So that's approximately 0.94. Okay, so the accurate solution would be for the point where they cross. The coordinates of that point would be 2 and 5/32, 15/16, which is approximately 2.16, 0.94. Maybe you can work out the arithmetic, use your calculator and stuff. They're hard fractions to deal with. So those might be accurate to two significant figures. There's more. Okay, this is going for several significant figures. Okay. Okay, this means that first place, remember my first ballpark, 2-1, pretty close to 2-1, but a little more than 2, a little less than 1. So if this is a little more than 2 and this is a little less than 1, I'm going to get a bigger result than I got for 2-1. Okay, and it should come up. If I use the exact fractions, and I would actually use them in improper form, 15/16 and 69/32 should give me exactly 9 and 3. Okay. So again, lesson is graph works as far as it does if you get it right. Okay, if you got a well-drawn graph, your intersection point is going to give you something pretty close to a solution, but you can't count on it to give you the exact solution. Now, in open math, a lot of times they'll contrive it so you get integer solutions, which is okay, but you have to understand that that doesn't always happen. Okay. Okay. So I'm going to give you another problem to work on. I'll leave this one visible. I'll visit when I leave. Okay, let's say I write the problem over here. And you see most everything, most every step up here. And I'll write the equations down here. And actually, I'm going to use your A's, B's, and C's. AX plus your By equals G. And I'm already having second thoughts. I don't want the numbers to get too complicated. So I'm going to say 4x plus ay equals G. And x minus by equals your F number. So go ahead and use your numbers, write out the system so I can take a look at it, make sure you have a reasonable system to work on, and then see what you can do with it. Okay. Let's say that my two equations were these. Now, everybody did real well with graphing. There are a couple of bizarre things that I couldn't identify. One of them I was able to identify, but on the whole, the graphs were done pretty much correctly. Maybe a little error here or there. There's one, I just can't spot the error, but there must have been one. So it's done well. I think y'all are good with that process. Okay, now, when we get to solving these algebraically, okay? If I multiply this by -12 and this one by 4, what's going to happen? I'm going to get -12 times this one. -12 times 4 is -48 x. And then it's minus 60y. And I have to multiply 12 by 17. Why did I do that for myself? Well, that's going to be -104. Okay. So that's what I would get if I did my arithmetic right. If I didn't, you can correct it. Okay. And then the second one, I multiply by 4. 4 times 12 is 48. Four times -7 is -28. 4 times 14 is 56. Okay. Now, when I add these, the -48x and the 48x are going to give me 0, aren't they? And that's what I want. I want to get either my x's or my y's to give me 0. It'll always work if I multiply this one by this number and this one by the negative of this number, or vice versa. Okay, that always works. It's usually overkill. It's not necessary to do that much, but when I add these up, I get 0x minus 88y equals -148. If I did my arithmetic right, I think it's right. And we solve this, we get y equals then 148 over 88. Now that reduces, you can certainly divide 148 and 88 both by 4. Okay, and you would get 37 over 22. And then we can plug that back into either equation and solve for x. Okay. Now, alternatively, if I multiply 4 by 3, I get 12, right? Okay. Again, I want to match the coefficients of x up. The easiest thing to do would be multiply this by 3 and this by -1, right? Or this by -3 and just leave this the way it is. Well, I'll do that. So I'm going to multiply -3 times equation 1, which would give me -12x, -3 times 4, and -15y, -3 times 5 is -15, equals -51. 3 times 17, 51, -51. Okay, in the second equation, I don't have to touch. That's just going to be 12x minus 7y equals 14. Then I can add the equations up. First equation plus second equation gives me -22y equals -37. Okay. And this is in some ways no better than this, but the numbers are smaller. They're easier to deal with. Okay. I can multiply those numbers in my head. Apparently did it right for once. Okay. You can't. Or at least you probably don't want to. Maybe you can. Yeah, if you're pretty good at multiplication, but since a calculator is put in your hand before you could walk, yeah, I guess, well, actually, you could probably walk by the time you were 10, couldn't you? It'll look pretty coordinated. I think you could make it by 10. Okay, well, okay. Point is, you get easier numbers if you make a better choice of how to match these up. Okay. The goal is to match one of these up. Open Math is going to coach you in that. They'll run you through it. In any case, this gives you y equals, coincidentally, 37/22. Makes no difference if I use the harder numbers or the easier numbers, as long as I do my arithmetic right and get these numbers to match up so they give me 0. I'm going to get a solution. If I do it right, the solution is going to be the same, no matter how bad the numbers I use are. Okay. You know, I could have multiplied this by 132 and this by 44. That would have worked, I think. Yeah, did that kind of quickly in my head. I'm pretty sure it does. You know, there's no number, there's no reason to go to overkill. Okay. But you do want to try to get the simplest numbers you can. And if you can't get the simplest ones, it'll still work. Okay. Just you gotta write out more numbers. So anyhow, that would do it. Now, of course, in either case, I would take this solution and bring it up into one of the equations. I'll go to this equation here, and then I can draw an arrow up here and plug in my 37/22 in for y, right? Okay, so I would get 12x minus 7 times 37/22 equals 14. Then I have to solve that. Well, I multiply everything by 22. I would choose these numbers. Okay. Well, this can be rearranged, so I get 22/22, which is just 1, and I just end up with 7 times 37. Of course, the negative sign will be there. Okay, 22 times 12x is 240 plus 24 is 264. Boy, I hope I did that right. 264x, maybe. Okay. And 7 times 37 is 210 and 49, which is 259. And 22 times 14 is 280 and 28, which is 308. Put a question mark on that, and I'm going to take my calculation. And you get 264x equals 308 and 259. That's going to be 450 and 17,467. So that X is 467 over 264. Now that's a lot of work to get a result that I'm sure was obvious to you as soon as you looked at these equations. You could see that was going to be the solution, right? Well, just in case that's a problem for you, don't worry, you can always go through this process and get it. Okay. Now, those solutions are approximately, what's that? That's about 1.6. That's about maybe 1.8. I don't know. I'm sorry. Yeah, okay. Hold on. Somebody saying that I did something wrong or whatever. Yeah, I knew I was going to mess something up. Obviously, 300 and 200 is already 500, not 400, right? Okay. So I should have had a 567 here. It would make it a 567, obviously. So let's correct that. So now, so your solution, your point X, Y, where the two graphs would have crossed, would be at 37 over 22, 567 over 264. And I'm saying that's approximately 1.6 or 1.7, I think 1.7. And that's 2.2. Okay, something like that. Okay, that might be accurate to the 10th, but I won't guarantee it. Okay, I have another guarantee. So we can plug that back in. Okay, so 4 times 1.7 plus 5.2.2 equals 17 question marks. We're checking. And everybody's doing that pretty well. Okay, well that's 6.8 plus 11 equals 17. Well, that's 17.8 equals 17. Okay, so maybe I did my arithmetic right, except for that 100%. That was just testing to see if anybody noticed. Okay, and then I can do the same thing with the second equation. 12 times 1.7 minus 7 times 2.2 equals 14. That's going to give me 20.8 minus 15.4. Oh no, come on now. That's not going to work at all. I must have made a mistake somewhere because that's really off. Yeah, that's nowhere near 14. Okay. So maybe my arithmetic was worse than I thought. I don't think I had a mistake here because I came out the same both times. Those numbers are in the right ballpark. That should have been 244. Okay, I think, which would make a little difference, make this number a little bigger, make that even worse. Okay, so I don't know, but there's the process, right? So the numbers that you have to deal with in your homework are going to be probably easier than the numbers we dealt with here. And there are things that you have to do that we didn't get to illustrate here. We wanted to get the basic process down. Okay. So I think you should be well prepared for this assignment. I'll tell you a little bit more than we were able to do here today. But that's usually the case. Okay, very good. Okay, I was looking so hard for a mistake, and that is 264, not 244. I was right the first time. So still don't know where things went haywire.